Hey guys, this is Michael from Conquer Chemistry. In today's video, we'll be working through some single replacement reaction practice problems together. So really quickly, what a single replacement reaction is, this happens when an ionic compound reacts with either an element or a compound made of a single element, and then it produces another ionic compound, an element or compound made of an element. And then we'll work through these three example problems together. So first example, zinc oxide reacts with sodium. The first step you're going to want to do is assign the charges. So zinc is an ionic compound. Zinc has a positive 2 charge. It's always going to have a positive 2 charge despite the fact that it's a transition metal. Oxygen is always going to have a negative 2 charge. And then sodium, it doesn't have a charge here, but let's just write what the charge would be if it was in an ionic compound. It would be positive 1. So now what you do is, since the element is a positive 1 charge, is a positive charge, you're going to switch the two elements that are positively charged, and then that's going to give you sodium with the oxygen, and then it leaves you with the zinc. Now look at we produced an ionic compound and then an element, in this case a metal. Now we're going to transfer the charges over to make sure the ionic compound is neutral. Sodium is a positive 1 charge and then oxygen is negative 2. These charges aren't going to cancel each other out, so to make it neutral we can do the crisscross method. We can take the 2 and then make it into the subscript, and then the 1 of the sodium turn into the subscript of the oxygen. And then now it's balanced, it's neutral. So since it's an ionic compound, this is going to be a solid, and then zinc, because it's a metal, it's going to be a solid as well. Then we double check if the reaction is balanced. You can see here there's 2 sodiums, so I'm going to need a 2 in front of the sodium on the reactant side to make that balanced, and then after doing that, the entire reaction is balanced. Great, let's go and do the second example. Again, we have an ionic compound reacting with a compound made up of a single element, so this is going to be a single replacement reaction. We're going to write the charges. Sodium first column, so it's positive 1. Iodine, because it's a halogen, it's negative 1. And then bromine, if it were to be an ionic compound, since it's a halogen, it would also be negative 1. Now, the element has a negative charge, unlike the element on top, which has a positive charge. So now we're going to switch the two elements that are negatively charged. So we're going to switch the Br and the I, and then that's going to give us Na, Br, and I. And notice, although there was 2 Brs here, I only brought 1 Br over to the other side. And the reason why I did that is because I want to make sure the charges are balanced before I add subscripts. So now I carry the charges over. Sodium is positive 1, and then bromine is negative 1. So you can see these currently do balance each other out, so there's no need to add any more subscripts. Now iodine, since it is a diatomic element, when iodine is alone, it's going to be in a pair, so it's I2. And iodine in standard state is going to be a solid, and then sodium bromide, because it is an ionic compound, is also going to be a solid. Then we double check if the reaction is balanced. There's currently 2 I's on the reactant side and only 1 on the, the 2 on the product side and 1 on the reactant side. So I'm going to need a 2 right here, and then that makes us have 2 sodiums. I need to put a 2 in front of here, and then after doing that, everything is balanced. Okay, last example, we have magnesium reacting with hydrochloric acid. So we have a metal reacting with a ionic-like substance, hydrochloric acid, since this is a strong acid. So again, this is going to be single replacement. Then we're going to write the charges. H is positive 1, and then Cl is a halogen, so it's negative 1. And then if magnesium were to be an ionic compound, since it's in that second column of the periodic table, it's going to have a positive 2 charge. Then we're working with positives again, so we're going to take our 2 positive charges and we're going to switch places. Then you get magnesium with chlorine and then hydrogen. And magnesium is positive 2 charge, chlorine's negative 1 charge. You can see these are not going to cancel each other out, so we could do the crisscross method, giving us MgCl2. And then H is a diatomic element, so it's going to be H2. This is ionic compound, so it's going to be a solid. And then H2 in its standard state, it's going to be a gas. Then lastly, we balance the chemical reaction. We have 2 hydrogens, so I'm going to need to put a 2 in front of the HCl. and then by doing that, all the other elements are balanced as well. So that's it. We worked through 3 examples problems. Hopefully that made some sense. Just to quick recap of what a single replacement reaction is. It's when you have a ionic compound reacting with an element or a compound made up only of single element, and then it's going to give you another ionic compound and then another element or compound made up of single element. All right, and if this helped, like the video, leave a comment about how it helped or what confused you and what could have been better, and then subscribe to the channel because I'll be posting up a lot of videos that's going to help you do better in chemistry and conquer chemistry. And if you liked my teaching style and you're interested in individual tutoring, check out www.conquerchemistry.com/online tutoring. All right, keep practicing, and I'll see you next time.